So today I want to give a preview for the conference coming up around some of the challenges that we are encountering in the financial monitoring space around the use of blockchain transactions. So just hitting some key points. The number one point, and this is probably no surprise to anyone, is that blockchain is a really different self-contained technology. It does not integrate well with our current systems that we use for financial monitoring. And this creates a whole host of issues that we are working through right now. Obviously, this is a very topical question too. So just to emphasize some of these issues, because blockchain is in and of itself not subject to validation outside of itself, that is an obstacle to a lot of current approaches that we use for financial monitoring. My focus is typically on transaction monitoring for anti-money laundering, but a lot of the same considerations apply for knowing your customer, for screening against sanctions lists, for market surveillance of trading activity, etc. What this means is that we have to try to leverage whatever we can extract from the blockchain and also whatever data sets are available. This brings up another huge challenge, which is, especially speaking from existing so-called fiat financial institutions, we don't have data for the most part on what's happening on the blockchain. We have a lot of data that is so-called off-chain. And there are a whole bunch of new vendors that are cropping up in this space who are tracking especially illicit activities, frauds, takeovers, etc., that are associated with specific wallets, digital wallets that are used for transactions, different exchanges, different practices such as mixing of different types of cryptocurrencies. All of these can be red flags, but none of those vendors has a comprehensive set of data reflecting that this sector is very new. And then there still remains that question of how do we reconcile the on-chain data with the off-chain data in a meaningful way. So specifically, this raises some questions around what does it mean to have a wallet address that's associated with potentially risky activity? Do we care if that wallet address is associated with other wallet addresses that are associated with risky activity? Where do we draw the line between direct seeming suspicious activity versus indirect? And then when we're talking about exchange of currency, in this case, crypto or digital currency, we also have to apply the so-called travel rule, which is a regulation in the US subject to any transactions over $3,000 that there's supposed to be information accompanying those transactions around who it's from, where it's going to. And this is not something that's on the blockchain. So everything that we're talking about is a kind of workaround. And right now there are a few organizations that are trying to address this specific issue, but no one has done it comprehensively, and it requires large-scale cooperation, which is not in place yet for all the reasons that I just mentioned. Now, this whole situation is occurring with the backdrop of major frauds and market failures in the digital and crypto area very recently. I don't want to go into those, but I'm sure people are very well aware. This is already considered to be a very high risk sector for those reasons explicitly by regulators. And I think we've seen in a lot of media reporting recently that because of all the recent blowups, it has just emphasized that there's an expectation from governments and regulators across the globe to pay a lot more attention very quickly to this sector, which I think we've seen I would say a ramping up of regulatory attention in this area, but now I think we really expect that to accelerate rapidly. So there's going to be more and more pressure on anyone trying to work in this space to care for AML, sanctions, KYC, where before there was some expectation there, and even in the past several months, several sizable fines that were levied on different new types of financial institutions in the crypto space. But now I think we're going to see a lot more enforcement, a lot more attention, and that's also going to spill over into existing financial institutions that are trying to integrate and address customer interests around the use of crypto assets. I know I just have maybe one more minute, so I'll just touch on a couple other things briefly. And one of those is that again, as a sort of overarching issue, there's real tension between the needs, especially regulatory and legal requirements associated with financial monitoring in the financial sector versus the ethos of the crypto space, which really has an emphasis on security and privacy. So those values go head to head, and it's not quite clear how that conflict is going to be resolved. And then the other point, and somewhat related, is there's a real deficit of skill sets in this area. To simplify, we have a lot of people who are in the digital crypto area, which is very new. And then we have a whole bunch of people who work on compliance, but not a lot of people who can really stand in both of those worlds, and that's what we need to have effective solutions going forward. So a lot of things happening right now in this world, a lot of institutions working to solve these problems, and not a lot of clear answers yet.
So what I was speaking of in the session, as there is so much of hype going on at present on ChatGPT, and I guess everyone of us are curious to know what this tool is about, what it's capable of doing, what are the limitations of using it in the financial industry, and how do we use this tool. So my session will be about understanding the architecture of ChatGPT to get into a little bit of technicalities. And after that, I'll be talking in details on how it can be used in the financial institutions, and what are the rules and regulations that should be followed, and what are the risks associated with it. But before I jump to generative AI, let's take a few, let's talk about what is artificial intelligence. We are talking about artificial intelligence so much, and suddenly there is so much hype on Gen AI. Now, AI basically just mimics human capabilities, and however, most of the AI we have been using for years till now was around clustering and classification. Again, clustering and classification are some of the capabilities that it's what are so clustering and classification are around taking decisions. That's what human does. Humans take decisions, and it is something which is very easy to replicate by a machine. But over the years, there is another human capability which was not yet addressed by artificial intelligence. That is a capability of generating content, capability of generating an image or a picture or a video. So that is a capability of humans which is very, very difficult to replicate or to mimic. So that's why all the advancement which we were seeing previously were in the area of taking decision in terms of classification and clustering. But why the sudden hype? Because it is more interesting and very, very appealing to the general mass, because suddenly people are actually understanding and seeing the content which we are actually seeing, that again AI is generating a whole summary or a entire picture. Apart from that, so let's just move back and see what was the first model of Gen AI before ChatGPT. The first chatbot was developed in 1966. So Gen AI, so okay, what is Gen AI? It's just a classification of machine learning algorithms. is capable of generating a wider range of content. That's what I said, like generating content. And if we move back in the year of 1966, that is where the first chatbot was launched by the name of Aliza. Now, Aliza is a program which was launched by a MIT professor to show the superficiality of communication between a human and a machine. It didn't have a very complex architecture. It didn't have a framework for contextualizing the events. It was based on pattern matching and substitution methodology that gave users an illusion of understanding on the part of the program. So basically, you type in some questions and you get back some answers from Lisa. But the main after that, the main contribution which happened in the area of 2014 with the launch of generative adversarial networks and variational autoencoder, which was producing remarkably authentic looking photos and videos and sounds of actual people. So basically, what took it so long from 1966 to 2017? One of the things which I think contributed to the lag is two. One is the development of deep learning algorithms, and two, computer infrastructure. So these are the two things which happened in the very recent years, improvement of computing infrastructure. As you see, all the large-scale language models, which is GPT-1, 2, 3, and right now ChatGPT, requires very high computing infrastructure, and both things go hand in hand. So the advancement of deep learning algorithms and the advancement in computing infrastructure, which happened in very recent years, give rise to the development of such very good generative models. Now, what I will be talking in my session. Okay, before that, let me give also a little bit more overview. We spoke of the first chatbot, we spoke of GANs, and in 2017, we have the paper by the Google researchers, which is Attention is All You Need, which is introducing the concept of transformer, and which is more of like the base of all the recent LLM algorithms that we are talking about. All right, so let's jump to on the impact of financial industry. So now what I'll be talking about is also what is a prompt. So the basis of ChatGPT is it takes prompt as an input. So we will be also talking about what is a prompt and what are the effective ways of using a prompt so that the output is more efficient, and what are the prompt strategies for better output. Now, this is like part of the technical aspects. Now, coming to the implementation or the downstream application in the financial industry. Now, in my session, I'll be talking about the different use cases where we can find the downstream applications of ChatGPT or other generative AI algorithms. And the other thing, we also have to take care of bias. So handling bias. So why is it so difficult in implementing these generative AI algorithms over the classification ones? One reason is the risk associated in so obviously there are some risk associated with any of the AI models. It is somewhat a black box kind of model. And whenever we are trying to associate the risk, it is very easy to calculate the risk associated when we are using classification or clustering kind of algorithms. But it is very difficult to associate the risk or mathematically calculate the risk associated when we use such generative AI algorithms. So there is how do we go about the risk, or how do we handle bias while using such algorithms in the financial industries? Because we should be aware that the financial firms will be held accountable for the use of generative AI and the content generated by the algorithms once used for commercial purposes. They shouldn't result in any legal violations. So again, one another limitations, or I would say a risk area of using generative AI is hallucination. More like sometimes these big LLMs tend to generate out of context facts or out of context contents, which might sometimes lead to copyright violations. And also, we do not want to use incorrect facts in taking any financial decisions. So how do we tackle hallucinations in while deploying such algorithms in the daily life or solving use cases in financial industry? And at the end, I will also go over some of the rules that we should follow for successful and ethical deployment of these algorithms in the industry. So that will be my session all about.
Morning, everyone. Thank you for the introduction. So I'm Swagata Ashwani. I'm a senior data scientist. I've been working in NLP and machine learning for over 6 years now. My topic would be how to build a question answer engine in using Python. So as in the previous talk and in general, we've heard about generative AI and ChatGPT, and so much around us is about question and answer. Even in our daily life, we ask Siri so many questions, or we ask Google in general. So it's very important to understand for people who really want to build their own question answer system, how to go about it and how to get started with what looks like the future of AI. So the question answer engine is essentially a system that can understand any natural language query that you provide and provide you with the relevant answer. So it's important for these kind of systems to be able to quickly give you the information and in a concise format. As I mentioned, in today's digital age and with the advancement in AI, this kind of problem has become more and more relevant. So it's important to understand the building blocks of it and how you can create your own system. So giving a little bit overview of what are the different types of question answer systems that can be developed. The first one is fact-based. So fact-based system can be simply answering questions which are based on a fact, as it says. So the questions on this category would be asking like, what is the capital of France? So there is just one answer to that. You cannot really have more than one answer. It's based on a fact. Second one is opinion based, and this is the most widely studied topic because this can have a lot of bias and it's a very subjective topic. So this topic is where maximum research is being done. So this category can have questions like, what do you think is the best restaurant in Paris? So this could be subjective and everybody can have their own answer. The third category is knowledge based, and this takes into account domain knowledge. So it does have a little bit overlap with fact based, but this category has more of domain knowledge. So one example of this category could be, let's say for COVID. So what are the symptoms of COVID-19? That could be one example of knowledge based. So while we are building a question answering engine, it's important to realize if you want to focus on just one of these systems or if you want to focus on all of these together. So the next part that I'm going to talk about in the session is data collection, because this is the heart of the system and this basically dictates how your system is going to perform. So collecting high quality data and massive amounts of data is important for building and getting accurate answers for your questions. And it's also important the quality of your question is really good. So collecting good quality data, factual data is important when you're trying to build such kind of system. So the next part after you collect the data is actually processing the data. So with text-based content, there are several steps that you typically perform before you actually pass it into the model So the first step would be just breaking it down into pieces. So let's say you have a sentence, you typically break it down into words or stems or the root word, and you try to perform some kind of stop word removal. So stop word removal words such as the, a, and these are not really relevant to the actual content of the data. So we kind of do some kind of stop word removal, stemming or lemmatization, which is basically getting the root word. You typically just want to understand the meaning of the word and not necessarily the grammar. So these kind of steps, tokenization, stemming, stop word, clean the data and make it ready for the next step where you put it in the model. The next step is actually building the model, and this is where you have multiple choices of what model do you want to pick. In some simple scenarios, it can be if you're just starting out and you just want to test out the entire pipeline, you could start with something as simple as a rule-based model or some of the simpler machine learning models like SVMs. But if you want to compete with the state-of-the-art architectures these days, the best approach would be to go with transformer models, which come under the deep learning umbrella. So in my session, I'll actually going to go through with two of these approaches. One is just using a simple machine learning approach, and one would be using the state-of-the-art deep learning model. And once you have the model, then it's important to evaluate and see how our system is actually performing. So there are a couple of metrics that we actually use to get the accuracy or the performance of our model. So most common metrics that we use are precision, recall, and F1 square. So we'll be going over the tutorial during the session that we will see how each of these metrics are calculated and how each of these metrics, each of the model that we develop perform using these metrics. And finally, of course, it's a really good project to do, but of course it has a lot of challenges and limitations. So the biggest challenge that could be is because it's a natural language model, and there obviously can be a lot of overfitting or bias in the system. And the second challenge is about the quality of the data. So like I said, like data is the heart of the system. So if you do not have good quality data, of course, it's going to affect the accuracy of the model. So we are going to take a look at some of these challenges during the session and try to backtrack and make some improvements in the model and see how it affects and how we can deal with some of these challenges. So in the session, I'm going to have a tutorial with a notebook walkthrough of how to do it. So if anybody wants to tag along and like go do it hands-on, there'll be a notebook that will be shared and you can just run through and get a sense of how it's doing end-to-end. That will be all about my session, and yeah, I'm looking forward to it.
Thank you, Lena, for having me here. Let me present my slides here. Let me see if this works. This is where technology comes in, so give me just a second here. All right, let's try this here. All right, can you guys see my slides?
Yeah.
All right, let me just get this here. So give me 1 second, my computer's acting up here. Actually, Lena, can you help me here? Can you share the slides for me?
I think she can do if she has the slide.
Yeah,
I can see
sure.
the slides.
We are able to see your slides.
We are able to see it.
Okay,
You
great.
may not be seeing it, I guess.
Yeah,
Yeah,
I'm
I
able
wasn't
to see.
sure if you guys can see my slides or not. But anyway, thank you for having me here and for the kind introduction.
Yeah.
So I'm excited about the conference. I'll share a lot of details in the actual conference of today, just a preview. And so the topic of my discussion really is, is AI truly the jack of all trades? So you'll notice a question mark at the end of my topic sentence here. And what I want to leave all of you with and the audience with when we do have the conference is exactly that. We need to determine on our own if AI is really solving all the problems or not. So that's for us to determine. So a little bit about myself, some of it was discussed earlier, so thank you for the kind words. So I've been in product for about 20 years, spent the first half of my career in semiconductors and mobile. and the rest of it at PayPal and Circle. I think, Leah, you would probably identify with Circle, a lot of overlap with what you're doing there. I'm also a speaker, mentor in many places, academia, invest, all of those good things. So what I really want to share with all of you, in the next couple of minutes and also in the conference is just a single goal that before we go and embark on using a particular technology, whether it's AI or if it's something else, is to really tie it all to what is the business purpose or why we're doing what we're doing. Again, as a product person, as a business leader, one of the things that I always like to push for is that tie it all to where you can drive value and utility. So AI, ML, ChatGPT, all these smart topics that we have and very, very accomplished speakers here. But I will leave you with this, that as you go about in your work, make sure you know exactly what you're solving for. Who is serving whom? Is it technology serving us or us serving technology? So my agenda for the talk on the 29th is going to be essentially talking about the purpose of AI in business overall. And again, AI has been around for like 30, 40 years. It's nothing new. It's just that it's becoming more consumerized, more visible now. So we'll talk about that. My background in the 10 years in the past, like I said, 10 years has been fintech, blockchain, crypto. So I'll talk about those things as well. And I think one of the speakers earlier touched upon the pitfalls in AI as well.
Sumit, 1 second. Can you put on presentation mode, like slides?
Oh.
Presentation.
Is that better?
We can see it, Lena. I can see it big enough, fonts and so on.
Yeah, now it's okay. Now it's okay.
Yeah.
Okay.
Good.
So we'll talk about some of the pitfalls as well. So really, if you think about what AI is enabling today, there's a multitude of things, right? From driving productivity, the user experience, the customer experience, all the way down to solving some of the most important, what we call the big, heavy problems in business today. But the beauty of AI is that the impact can be very measurable. So again, as you go about doing the things that you do in business, it is really important to know what you're trying to solve for. But the bottom line is, there are very clear indicators that AI is actually driving the top line. It helps you manage the bottom line and also ensures ROI. But again, it really ties back to what you're trying to solve for. So I'll talk about some of these things as well in my overall presentation. I won't spend too much time on this slide here, but again, this is just a depiction of the different things that AI is solving today. As you look around your daily work in your professions or your daily lives at home, I can guarantee that this AI is embedded somewhere, somehow, every minute of your living across these things. So, I was in telecom and mobile, semiconductors, my wife and some family members are in healthcare. We've got family members in all of these things here. So a whole variety of different use cases. The other thing I'd like to mention is that, it's not, you will be solving different use cases using AI or machine learning or deep learning. So you need to know what to use when and what is applicable for what particular scenario to drive that value. So we'll talk about some of these use cases as well in the actual talk. But again, because I spent so much time in fintech and blockchain, I'll be focusing on those in the actual conference. So this slide here really talks about, where in the entire customer journey or a business's journey, AI is really embedded in fintech. And I think a lot of you who are in the fintech space or crypto or work in financial institutions will recognize these main themes around where AI is embedded right from the time that you're actually offered something as a product by a company or a vendor, which is all based on decision science, it's based on creditworthiness models driven by AI, all the way to you being verified in the systems. And then you have, things such as the payments authorization that takes place when you do a checkout. Those are all based on risk-based algorithms. Those are what these companies do. Now, when you take a look at all the things that are happening today with robo-advisors, all the chatbots, customer service, all in the back end, it is all AI-driven. I think somebody also mentioned, KYC, KYB, which is the very, very fundamental backbone ingredient for all financial services. So a lot of that today is being driven by AI models to do these things quickly. The other thing that happens, which we actually forget, is the regulations change when you go from one geo to another. So AI is also helping manage those changes worldwide in financial products, in fintech. And of course, if you fast forward to a lot of things in the future, a lot of the sell side, buy side markets, they buy research that is AI generated. So they can make transactions and trades and make recommendations to different folks for buying and selling capital products. So we'll talk about some of these things in the presentation, but really the point here being that fintech is probably one of the biggest use cases for AI, and it is becoming more and more dominant. So we'll touch upon this on the 29th. Blockchain and AI. I think this is the jargon slide. A lot of topics here to cover, and I won't get into every single thing that's on the slide here. But the key takeaway is that the future technology that we just talked about all these days is blockchain. What's happening in finance and crypto and all of those things. But if you really think about it, blockchain is just a ledger, right? It hosts data. That's really what it's doing. Now, blockchain is being used across multiple industries, literally multiple industries. But obviously, I want to focus more on financial services because that's where blockchain is being used the most in the most dominant fashion today. And you'd be surprised, or maybe not surprised, that there are a number of blockchains increasing by the day that are servicing these use cases. And the data that is serviced through these blockchains is not megabytes anymore. It's going from gigabytes to petabytes and beyond. Now, how does that help? You marry that with AI. AI is all based on data. The more data, the more performance you can get out of AI engines. So really for the future, if you really think about it, in financial services specifically, you marry blockchain with AI, what do you get? You can truly drive the promise of fintech. I said this in the beginning here, that the main purpose as a business leader, as a product leader, is for you to understand that you're trying to drive value for the customer. And if you can take all this data being generated on the blockchain, on-chain, and you marry that with something as smart as an AI engine, you can truly try to deliver access in places where there is no access to financial services, whether it's credit or other things in different markets, developing world and so on, faster, cheaper, more secure. And it opens up use cases like decentralized finance, decentralized marketplaces, e-commerce enablement through authentic validation of the goods and services being sold, compliance and regulation, auditing, traceability, threat detection, and so on. So there's a lot of things that can be used and done by marrying blockchain and AI in financial services. So we'll talk about some of these things as well on the 29th. So this is just a preview. And going back to what I said earlier, there's technology serving us or we're serving technology. If I give you a hammer, everything looks like a nail. And AI today really is like a sledgehammer. Everybody wants to solve everything using AI, but that's really not the case. And as a leader in the business, you have to be very, very careful about when and how you use AI and what the output is. Again, some of the speakers touched on this, but AI is not perfect. But rest assured, it is going to be a co-pilot for you in your business as a product or business leader. It is not going away. It'll become something and someone that is going to help you drive products forward. But we have to be aware of the biases that it introduces, especially what we call ethical finance. And of course, the other things that I've listed over here in terms of privacy, security, who owns the liability if something goes wrong? How do you create trust with the consumer and so on? So we'll talk about these things as well on the 29th. And again, if I was to just leave you with one thing as a person who's driving value using technology, is to first think about the customer and then try the solution using AI versus the other way around, right? And again, is AI truly a jack of all trades? In my opinion, it probably is in many cases. Is it a master of many? Not yet, right? But that's something that you have to decide and move forward with. So do attend the session on the 29th, 30th, 31st, and I'll be talking a lot more about these topics.
Thank you, Dr. Murthy. And first of all, thank you so much for this introduction. I think you exaggerated lots of things about me, but yeah. So basically, first let me share my slide. Let me know if you can see my slides.
Yeah, we can see it.
Yeah. So Thank you, everyone. And so my talk will be like very different than what you have seen, because this is more like a panel talk, and I'm a part of panel. The topic of the panel is AI for healthcare. Along with me, I will have like 3 more experts with me, everyone from different domain and coming with different expertise. Healthcare is one of the very, let's say, exciting frontier of AI. As a human being, survival is one of the things we always seek for, and providing a good healthcare should be everybody's right. As we have seen that like AI is touching various frontiers, this particular topic, like AI for healthcare, is becoming very important today, as we know that our healthcare industry itself has like lots of challenges, and how we can address some of those challenges using artificial intelligence. So this is the list of all speakers. So as you know, I'm Rohan Rajput. I'm a senior data scientist at Headspace. I lead a team of personalization. Basically, my task is to provide a personalized recommendation for our users. Along with me, we have Dr. Sundaram. He's a manager at PCCI. It's a subsidiary of Parkland Hospital. Do various research on patient outcome. Along with that, we have Dr. Gangopadhyay, Ahana Gangopadhyay. She is also a senior data scientist at GE Healthcare. She works lots on medical imaging, really helping GE Healthcare to proceed further with like lots of her skill in computer vision. And then we have also a panelist and our moderator, Ratan Kumar Udaya Kumar. He is a product manager at Netradyne, and he'll be moderating our talk as well as providing insight from a product manager perspective. So we have seen that we have like 4 different domain expertise here, and we'll be talking about various topics in this particular panel talk. So just giving you an overview, what are the things we can cover in that panel. So first, obviously, we want to revolutionize the healthcare. One of the important things we have to know that if we have seen recent data from inflation, one of the things that has been impacted highest by this recent inflation is healthcare. Hospital service, administrative service cost way more than what we are having before, and especially in the United States, we know that there is a huge burden of administrative burden on hospital and healthcare services that directly come to the pocket of end consumer and patients. So how AI can help us to improve the patient outcome, improving efficiency, and reduce cost. And all of this thing can be done using various applications of artificial intelligence. As we can see that if we introduce more automation, like a more diagnosis, more preventive care, all of these things can be really improved by using AI. So there are different topics of, as you know, in AI, one of the very common theme in AI is machine learning, which is learning from large amount of historical data. In that front, we have seen that how this different subfield of AI can help us in improving healthcare. So we have experts talking about how natural language processing can help us to improve various processes reading doctor notes, understanding from large corpus of data that what is going on through a medical history of a patient. We have computer vision. We can analyze a huge amount of medical images to see that what type of preventive care should be provided to the patient. Can we do early diagnostic? As you all know that there are some very serious disease in this world that can be prevented if we can do earlier diagnosis. We have huge amount of let's say different wearable devices available today, and we have huge amount our phone itself can help us tremendously in various frontiers. You might have read lots of paper that there are some application that can early diagnose skin cancer. There are some applications that can help us to early diagnose breast cancer. There are various imaging software that can read lots of like X-ray and MRI scans and all of those things, those medical images, to find out that what can be done for this particular patient and what are the preventive cares we can do in advance. Third and last in robotics. Now, robotics, it's a little bit like more, let's say, little bit right now far-fetched for now. But we have seen that like there are various researchers ongoing to do like medical surgeries in for patients, and how can we can bring more automation in healthcare that can help our patient to release lots of these burden which currently they are having. So when we talk about AI and healthcare, both of them are very, very sensitive topics. Sensitive in the particular sense that we have lots of ethical and legal challenges in the field of AI and healthcare. One of the most important factors is privacy. Like everybody is aware that data is a new asset today, and privacy is becoming more and more important. So what are some of the challenges in the field of healthcare and field of AI so we can prevent lots of abuse what sometimes happens in the domain of healthcare and AI? How can we make this system more secure? If there is some inherent bias in data, or like the process of collecting data, or if our model is getting some kind of bias from the system, how can we remove those biases? And how can we measure some of these impacts on our patient, providers, and policymakers? So we have to make a system that is fair to all of these three stakeholders. So we'll talk about all of this thing, and along the thing, we'll also share like some of the technical challenges. Like as a practitioner, I can share that what are the problems we face like when we deploy these large scale systems. And also as a project management side, we'll hear from Ratan that what are the challenges we have when we handle AI projects, which are like very different than traditional software engineering. So with that, I conclude my presentation right now. And please attend me on like March 31st at 2:35 p.m. on this panel talk, and we'll discuss many things in that talk. Thank you so much.
Make it quick, like a 5-minute presentation. So what I'll do is I'll offer a hands-on workshop for a new generation of adaptive algorithms that came out of a research project that I did with Purdue as well as with UCLA. This was a long-time research that I did on and off, even while I was a practitioner of AI in various jobs I've had, most recently at NVIDIA, before this at Google. And the need for adaptive algorithm grew over the years, so I thought it timely to publish a book on this, but I'm not trying to promote the book, I'm trying to promote the algorithms. So this is a very critical need at this point, because what we have is large volume data, and data is high dimensional. You can see my slides, right?
Yes, we can see.
Okay, data is high dimensional, and one example of this is edge devices. So you have many, many, many devices at the edge, including your mobile phone. Even though the compute capability in these devices are going up, the batteries are not. The battery lifetime decreases if you do a lot of compute at the edge. So there is a need for doing a low amount of compute and get very high reliability machine learning results. So power usage is an important criteria. The data is time varying and non-stationary. The latency is important, because if you send the data to the cloud and to the compute and bring the models down in a federated learning model, then there is latency between what you learned and what you have right now. So you want to have a continuous learning process that is very fast and easy. And then you also have low memories in many bandwidth. If you look at a country like India, where there is like many hundreds of millions of devices, but most of them are not iPhones with a very high amount of compute, or Samsung phones. They are low quality phones with a very low amount of compute. So if you want to do local compute or do recommendations, then you need to have models that are very fast, that are very easy and adaptable in an edge environment. Okay, in this environment, data cannot be batched because you do not have as much memory on the phones. The data changes with time because a lot of people are mobile, the location changes, everything changes. The data volume and dimensionality is large. So for example, if you make a purchase at a place, then there is so many things, products, SKUs, prices, location. You can have 100-dimensional data, right? If you have text data, then when you do a one-hot encoding, it becomes a 100-fold data. So we take some use cases in this hands-on workshop. One is to calculate drift of incoming data, which is typically known as training serving skew. This is a very key aspect of model monitoring. So you have the model training, you have the model repository, you have the model inference, but model monitoring is very important because you train the model with a certain set of data, and all of a sudden the new data is no longer same. So how do you make a determination of training serving skew so that you can quickly train the model, or you can say, or you can tell your cloud model trainer that you need to go in and get us a new model with the new data. So how do you adapt your model to incoming data? How do you calculate anomalies in incoming data? How to compress incoming data into features so that you can send it up to the cloud in order to do the model training. So we also look at many matrix algebra problems such as eigenvector, generalized eigenvector. Eigenvector is known as PCA in model feature extraction terms. So these are model compression techniques. We take many real-world examples such as so that the data arrives in real time, so that we compute the data very fast. We update the models very fast. So in the agenda of the talk, we have, it's a bit of a theoretical presentation. But I give hands-on examples with Python. All the code is there in the GitHub, in this particular GitHub, which is public. And for some reason, I cannot access the GitHub. So this GitHub has all the code and one can download. I would also like to, this is all the code all written in Python. I wrote them personally. This is the setup. If you don't have Python set up in your laptop, then this notebook, this notes will be very useful. I'd like to distribute this ahead of time and not spend a lot of time during the presentation to do the setup. I have allocated some time in case somebody hasn't done it. Otherwise, I will go ahead and show you how to do a PCA, how to do principal component, minor eigenvectors, and then I will go straight into the real-time applications, which is the last section of my workshop, which is calculate drift, how to do detect of the drift, how to adapt to incoming drift. Now, if I have time, I'd like to take anomaly detection problem or model update problem. So I'd like to take real world applications and spend most of the 2 hours in solving people's real. So here's an example how the data was fully trained, and then suddenly new data came in and how the model quickly adapted to the new data. So these are examples I will take up. There's a very important use case for billions of edge devices where memory is low, power consumption is critical, battery life is low, and also data volume is high. So that's my talk.